Okay, today's lesson and the lessons we're going to do up through mostly close to Christmas will be about statistics, probability, stuff like that. So we're going to do some activities that are a little bit different than our normal, so hopefully you'll enjoy the change of pace. So what you see in front of you is your notes, are your notes for today. You must watch this and write down everything that you see and take good notes, and then take a picture of your notes and send it to me. Okay, so today we're going to do this thing, who will win the last banana. Suppose that you're on a desert island playing dice with another castaway. The winner's prize will be the last banana. Here are the rules of the game. You roll a die and another person rolls a die. If you get numbers that are less than or 4 or less, then player 1 wins, and if you get numbers that are 5 or more, player 2 wins. So, who do you think has the advantage in this game? Player 1 or player 2? Or neither? Make your best guess and explain your choice. Okay, so it would appear that player 1 has the most probability of winning because he has 4 numbers, 1, 2, 3, and 4, versus only 2 numbers, 5 and 6. Okay, so let's try to figure this out. So you're supposed to roll a die 20 times with your partner and record the winner of each game by tallying the table below. You can do this if you want. I understand if you don't have any die, that's okay. We're going to go on and teach you what you need, and then tomorrow I'm going to give you an assignment that's a lot like this. Okay? So, let's see here. Play the game. Let's see. Number 3, who won more often? Maybe this was only true for your group. Let's see how the rest of the class did. Write the number of wins for player 1 in the table on the board. Find the total proportion of wins for player 1 for the whole class. Okay, so we're not going to do this, obviously, because we're not together in class. But you're going to have to do this on a different type of an example on your own. Okay? So let's go to the next page. And let's look at the true probability. So theoretical probability is the true probability. Theoretical probability means what are the numbers supposed to show, versus experimental probability, which is really about the outcomes of thousands and thousands of tries. So the experimental probability should end up being very close to the theoretical probability if you do it thousands of times. Obviously, if you roll a die once and you only get your number, then you've won 100% of the time. Of course, that's not true probability. So you have to do things lots of times. So on this chart here, in number 4, to determine the true probability of player 1 winning, you should list all the possible rolls that we could get. Okay, so complete the table. So both of you are rolling a die that has 6 sides on it. So you both roll a die and you could get 1 and 1. Okay, 1 and 2, 1 and 3, 1 and 4, 1 and 5, 1 and 6. Okay, so what do we have just with this one type of probability here when the other person only rolls a 1? Well, you have these 4 that are only 4 or less. And the right 2 still aren't just 5 and 6. They have a 1 with them, so they don't count for the winner of the bigger numbers. So just in this first type, player 1 would win 4 out of 6 times, and player 2 would win 0 out of 6 times. Okay? And nobody wins 2 out of 6 times. So if you add all these together, you're going to get 6 out of 6 or 1. And that's how they all should be. The whole chart should be a 100% value, okay? Where they should all add up to the number 1. Okay, so let's finish the chart here. You roll a 2 and a 1, a 2 and a 2, 2 and a 3, 2 and a 4, 2 and a 5, and a 2 and a 6. Now I'm going to go ahead and fill this out instead of saying each one. Oops. So what you should do is notice what all the winning values are. So they both have to be either big or they both have to be small. They can't be part or only half. Just like what we have in the yellow circle up there. Okay, so what do we really have here? Well, if I circle all the ones that have 4 or less in them. First of all, how many total numbers are there? Or excuse me, how many total blocks are there? It's a 6 by 6. So there's 36 altogether. Well, how many have only the numbers 4 or less? And you should say 16. Okay, and you can reduce that, but we'll just leave it out of 36 for the moment, just so we can check player 1, player 2, and nobody. Okay, oops, I did that back. No, that's right, that's right. Okay, so player 1 won 16 out of the 36 tries, is supposed to be. This is theoretical probability. That should be the probability that you can win. And player 2, let's see, let's make player 2 blue here. And just the big numbers, 5 or greater, would be there. If they have anything less than that, then it doesn't work. Okay, so if we take a look at that, that's 4 out of 36. And nobody won, let's see, 2, 4, 6, 8, 10, 12. Let's just do this. 2, 4, 6, 8, 10, 12, 14, 16. Okay, so 16 out of 36, nobody won. All right, you add those all together. 16 plus 4 is 20, plus 16 is 36. Okay, so 36 out of 36, or 1 or 100%. So we'll get to understanding whether or not to put a percentage or not. Either way is fine at the moment. Okay, so use your table to find the probability of player 1 winning. That's 16 out of 36. Okay? If you use your calculator and you divide that out, you can get your percentage. 16 divided by 36 is 0.4 repeating. And I'm just going to write this out 3 places. Because if you want to make this a percentage, you have to move your decimal 2 places to the right. So this would be 44.4%. All right, so you could say 16 out of 36 or 44 out of 4. Okay, 44.4%. 44% chance. Okay, so 44% chance sounds like you have less of a chance than anybody else, but you got to remember the other person only has 4 out of 36, which is 11%, 11.1%. Okay. All right, which was closer to the probability found in number 4A? Your group data or the whole class data? Obviously, if we had the whole class, it would be closer. The more that you do this, the closer you're going to get to theoretical probability. Remember, experimental probability, you're experimenting, you're just trying things. Theoretical probability is what you should get. All right, so if you look down at the key ideas, probability is a long-run frequency. Okay, meaning if you only roll the dice once, obviously it's unpredictable. Long-term is predictable. So you want to do long-term, meaning you do it multiple times. Theoretical probability, what we expect to happen. Experimental probability, what actually happens. Okay, so you got to remember those things because they use these words in the book and on your SATs that you're going to be taking next year. Okay, probability rules. The probability of event A. Okay, the probability of event A is just whatever the theoretical amounts are, the count, let me just put it in my own words, the count of what you want, meaning the total, okay, the total possible of what you want. Not if you're only rolling it once, you're only going to put a 1 up here. That's not true. The total of all the things. So like if you want to use a deck of cards, and then the bottom is just the total of everything. All right. So let's use a deck of cards to make sure we understand this. So if I want to draw one card, the number 1 is not going to be on top. Okay. We're not doing that. You want the total possible of what it is you're looking for. So if I draw one card, I want to know the probability of drawing a heart. Okay, so in this case, I would write it like this: the probability of a heart. All right, well, how many hearts are there? The total count of what you want. All right, the total count of hearts are 13. Ace through king, right? So 13. And then the total of everything. Well, how many cards are there? There's 52. All right, so here we're talking about probability in a simple form. You're only going to draw once. Okay, so the number 1 doesn't go on top. Make sure we get this. This is a big deal for students, and this is what's typically missed. Very big deal for you to understand. It's the total possible of what it is you're looking for, not how many times you're drawing. Okay? Now, the bottom is the total of everything that you possibly have. Doesn't matter if it has stuff in it you want or don't want. Okay, so the complement, the probability of not A, is 1 minus the probability of event A. So when you see the word complement, it wants the opposite of that. So in our example here, let me change the color here. We want 1 minus the probability of a heart. The complement of that would be this. 1 minus, well, take 13 away from 52, and what do you get? 39. Okay? I'm sorry. That's the answer. So let's write it right here. 1 minus the probability of that is 13 minus 52. And that's going to be your 39 over 52. So that's the complement. Meaning, if you add both of them together, you get 1. 13 over 52 plus 39 over 52. That's going to give you 52 over 52. Okay? So let's make sure we understand what complement means. Because sometimes if somebody asks for something, you may not be able to give that information because you don't think you have enough information, but you do have information on its complement. So you can get your information if you know part of what it is you're doing. Now, this next thing here is pretty big, or. The probability of A or B. That means this, the probability of A plus the probability of B. Make sure you understand or is plus, okay? Now, if you see the word and, it's not on here, but I'll just go ahead and tell you. If the probability of A and B, that also can be written like this. The probability of A then B, same thing, then means and then B. That means you're multiplying. All right, so that's not on here yet, but I'm just putting it out there. Or means plus, and means multiply. All right, at least 1. Okay, that's like the complement. Would be 1 minus the probability of 1. Okay? Or more. So when you look at this, it's easier to take the complement of what you get. All right, so the probability of getting 1, take 1 minus that, and that's going to be the answer of at least 1. Okay, probability models list all possible outcomes. Okay, so if you're drawing a model, this is what you should do. You list all possible outcomes. All the probabilities should be between 0 and 1. Meaning you're doing fractions for everything, like we did with the cards. So all the probabilities that you find should add up to 1 if you're drawing all the probabilities. Okay, so let's go to the next page for the check for understanding. Okay, what is your favorite color Skittle? Based on a very large sample, here's the distribution of color for Skittles that come in fun-sized bags. Okay, if you notice, we're missing the red. All right, so somebody did this. This is their probabilities that they got in decimal form. So they took the fraction, the top divided by the bottom, and they got those decimals. Okay, so let's look at number 1. Explain what the probability of 0.214 for purple means in this setting. Well, you have a 21.4% chance of getting a purple color in a bag if you draw 1 out. That's what it means. Find the probability for red. Okay, well, red's missing. So how do we get that? All these should add up to 1. So take 1 minus each of these numbers, and that'll give you what the probability for red is. So let's go ahead and do that. 1 minus 0.171, and you should check me with your calculator. Minus 0.214 minus 0.204 minus 0.214 again. And so that should be 0.197. So just like in a triangle, you have 180 degrees, you usually subtract 2 of the angles from 180 to get the third angle. Well, here, all of these have to add up to 1. So you have 1 missing, so subtract all of them from 1. It's just like the triangle. Okay, so the probability in percent form for having a red would be 19.7%. Again, just move your decimal 2 places to the right. What is the probability that a randomly selected Skittle is green or purple? So here you go. You have the word or. So let's write this out properly. The probability of green or purple. That equals the probability of green plus the probability of purple. This is how we want you to write these things. You can write the actual word if you want. So the probability of green, okay, is 0.171. And the probability of purple, which I do not have on here, I could make it, but I'm not going to, is 0.214. And if you add those together, what do we get on your handy-dandy calculator? 0.171 plus 0.214, that equals 0.385. All right, so if you're drawing one Skittle out of a bag, the probability of getting a green or purple on the one draw is 38.5% chance. That's a pretty big deal. What is the probability that a randomly selected Skittle is not yellow? So this is a complement. 1 minus the probability that you do get a yellow. So if it's not yellow, it's all the others. Now you could add all those others up, but let's go ahead and use the complement. 1 minus, what's the probability of yellow? 0.214. Okay, so let's say we didn't know the red. We could find it, but we wanted to know this probability. All we have to do is 1 minus the 0.214. Okay, so 1 minus 0.214 is 0.786, or 78.6% chance of getting anything that's not yellow. That's a pretty big probability. Okay, so that is your notes for today. I want you to write down what you've learned, the main points, and I want you to send it to me. I want to know everything that we've talked about. So write down the important points from today. Tell me what you learned, and then send that to me. That is your homework assignment. Good luck, because tomorrow you're going to have to do one of these types of experiments and come up with all the answers. All right, have a great day.